you guys. Then it's bad. Then it's bad consultant. All right, anyway, let's get into containment. I have a bunch of examples. We're freaking late. And if you need to take a break, get up, stretch, get up, break, take a stretch. I'm just going to keep motoring. But, you know, if you need to get up and run out of here screaming and hit the bar. All right, general containment. And again, this should be a refresher for you guys. Two types of containment, right? General containment, sized containment. Apply to two different classes of things. Sized containment, what does it apply to? Bulk storage containers. And loading racks, right? Now, bulk storage containers, portable or stationary, except for mobile refuelers, non-transportation related tank trucks. We're going to get to that. Anyway, general containment, again, typical failure mode, typical volume, could be active or passive. Size containment really needs to be passive. Constructed, engineered. For 100% of the capacity of the largest container or compartment plus whatever adequate freeboard is. Typically 24 hours of a 25-year storm. Your chart will help you because it says for portable containers, mobile refuelers, equipment, sized versus general. So that's what the table's for.
So you're saying for a 25-year storm event, which typically in the past people have used just 10% of the total size.
The adequate, no. The adequate, it has to have, for size containment, right, sufficient capacity for the 100% of the contents of the largest container or compartment plus adequate freeboard for precipitation. Who determines adequacy? Registered professional engineer. Commonly, 24 hours of a 25-year storm for that region. Oftentimes, they'll use 110%, whatever they determine to be adequate. All right, more and more, it's going to 24 hours of a 25-year storm. You know, particularly for, you know, for a number of containers in there. But it's up to the engineer to determine whether that's adequate. The bigger problem really is not that they picked 110% versus 24 hours of a 25-year storm. The bigger problem is the stupid facility left 5 inches of rainwater accumulating in there, didn't pump it out. Now they have insufficient containment. That's the bigger problem. Yeah. Right. So, and if you need to get the 24-hour, 25-year ISO pleths for how much rain in what region over a 24-hour period, for Northern and Southern California, that's on the calcupa.net website under the above ground tank program. If the really cruddy PDFs, you better zoom it in good, you know, and sit on that. All right. Anyway, so you know, facility diagrams, secondary containment. These are all general containment areas. The loading area by the tanks, wherever you're driving in the drums, right? Your oil-filled equipment areas. These are all general containment areas. Very typically, what do facilities use for general containment? Active measures, spill kits, active response. Make sure it's credible. Don't say, yeah, we'll respond to a spill. We have spill kits and have 1 drum of half-filled sorbent, right? You know, this is a loading area. That's a 3x3 dead, or 2x2 dead sump, little curbing, right? This is the tank and secondary containment, closed drain valve. Is that their general containment for the loading and unloading? Yeah, right? Pads, either before a spill or in response to a spill, right? Be careful about your active measures. You need to be able to implement them, drill and train on them, make them credible. The EPA inspector guidance, the checklist that's going around, wherever it is, under the discussion of looking at general containment, there's a great short discussion, but it's great on how do you know it's adequate. It kind of goes through the kind of questions that you may want to ask. Don't let whoever's writing your plan, internally, corporate, outside consultant, whoever, don't let whoever's writing your plan write you into a corner. Make sure you're real well communicating, you know, or coordinating on, okay, here's what we're really able to do. Don't write us down for something that we can't do. All right, so anyway, I like passive measures are always best. All right, sometimes they're more expensive initially, but passive measures are best. But again, it's up to you and the certifying engineer, right? Spills and preventing spills are like transmission repairs, right? Never get cheaper, always cheaper to fix it early, always cheaper to prevent, right? You know, a lot of procedures are, oh yeah, in the event of a spill, right, we're going to have the truck driver shut this off, right? They'll shut off the valve, they're going to get to the drain, they'll cover up the drain, that'll be fine. How's the truck driver going to do that when they have a face full of product? Well, maybe they didn't follow the proper procedure, maybe they didn't wear the proper personal protection equipment. They're not able to implement their active measures. This is where I really would have preferred a safe drain or some other provision to contain that, you know, even something that's not going to certainly hold the volume of the tank, but something so that, you know, that'll help so that somebody can respond, shut the flow off, it still retains it, because this guy didn't stand in the right spot to shut that off. Right? Think about the what-ifs. You know, it needs to be implementable. Right? Again, I love these safe drains. They can be, they're custom built, they seal in there, keep them open all the time, shut them when you're loading, or in the event of a spill, keep them closed all the time, only open them up to drain, you know, clean rainwater. You know, one of my facilities, we just rewrote their SPCC plan. They have 30 drains around their facility located on a peninsula in the port, right? Something hits the storm drain, about 10 seconds it's out in the harbor. They have a lot of fuels out there, right? They installed safe drains everywhere. Fabulous. Doesn't matter where they move their stuff, their general containment, safe drains, all passing. Fabulous. Maybe not be this, the saturated, you know, saturated barriers. Spill supply is very nice. What do you want to check? Make sure inventory's there. A better sign would be just ducky. Spill kit. How do you know that's the spill kit? It says spill kit. How do you know this is a typical spill kit? Because that's what's inside. I would not list the contents of the spill kit in the plan because they may change. I would not list I would not list the brand of spill kit in the plan. I would say typical industrial spill kits designed for oil are in the plan. Yeah, and they're generally in this area. This is so you don't kill somebody carrying a storm drain cover that weighs 80 pounds. They put it in a tube, they cover the tube, they put a handle on the tube, they put the tube on one of these carts with sandbags to, you know, be the sacrificial, keep the pad down, and they have a spill of the drain. They just grab this, run it down. This is terrific. This tells me they tried to do it manually once. This is a lot more believable in an SPCC plan than, you know, just having something on the wall. But having something on the fence, these are lightweight. They have a handle on it, you know, and the storm drains are right there. And these guys drill and train all the time. Now these guys have safe drains and these, and the drains are closed all the time. This is the safe drain door handle that's open. That's a boat. Yeah. All right, anyway, just an example of realistic, you know, this is the navigable water out here down in the creek, right? And is a spill kit likely to be, you know, believable as general containment for loading in this area? That's pretty close. I'd question it. You know, so again, just is it? You know, look at the criterion that EPA's Appendix G. You know, take a look at that. This facility, they have a bunch of oil-filled equipment, and this is one of my power plants, right? Oil-filled equipment all on the inside of the facility. Everything inside drains to the separators, right? But just in case they had something sized, they poured these drive-on, drive-off berms around the entire operable unit. There you go. Perfect. Yeah, and just, that way if any of this stuff leaves, it stays in there. Yeah. Yeah, you know, at some facility, like their warehouse facility across the bay, right? Big, huge warehouse. They're going to store like 400 drums, right? P-certified plant, all inside. How much containment do they need for the 400 drums? Fire code aside, it's not a fire code issue because they're class 3Bs, right? 55, all right? Individual pallets or really good peel and stick or molded, installed like 1-inch or 2-inch berms around the roll-up doors and the exit doors. That was it. It'll hold it. OSHA stripe, just in case. Anyway, just an example. That goes to the separator. You know, they need a safe drain. They just need something. They need to block this drain. because that's way too close. Way too close for the loading. That double-walled tank, way too close. I don't care what kind of spill kit they have, unless that spill kit is jammed into the drain. You know. That's a wonderful, brand new installation. Brand new installation. No, that's the whole thing. Anyway, size, containment, catastrophic failure, right? Let's look at some pictures, shall we? Right? It applies to all these various types of things. We've already been going through that last couple of days, running out of time. Right? Here's our intrepid engineer, Menkes, at a power plant, sweating because we went out there before they put the sunroof on. These are dead sumps, but the entire facility goes out to this gigantic retention basin. Fabulous. Cogeneration facilities, i.e. money printing facilities. Right? An alternative, what if there was no curbing anywhere, but everything in the facility drained to this 3 million gallon retention basin? That's allowable by the rule, as long as it retains it in there. Yes? That would be a, well, does secondary, what kind of impermeability does secondary containment have to have? Sufficient for what? Sufficient to retain oil within the containment to prevent a release to navigable water until that oil can be removed, right? You may find unlined. I would be concerned about unlined walls, but it could be a gravel deck. What the hell kind of ringer you have on your phone, right? It could be, the issue that you're going to have is if you're close to navigable water, it could squirt out the side, right? And then there's groundwater issues. But as long as it holds the oil before it gets to a navigable water, that's sufficient. That's fine.
Then why are we always getting nabbed for cracks in our containment?
In the floor of the containment?
Or the sides?
Because it may squirt out the sides. Did you say in your plan that you have cracks? We'll talk later. Anyway, all right, so this is a facility, a bunch of bulk tanks, temporary tanks, right? This facility, I think I have a picture of it, right? Yeah, this facility, I was driving back from thermal. There's a reason why they call it thermal. Holy God. My electronic temperature gauge didn't read that high. All right, it was in August. The huge bulk plant, right? I saw no containment there, not one bit, right? And I took a bunch of pictures from outside the gate standing in the street. Now, when the facility manager in a cowboy hat and a rifle rack finally chased me down in his truck, true story, you know, yeah, the rifle rack was empty, which led me to believe, you know, hey, these are big tanks, big containers, right? You know, and they're all yelling at me from inside the facility. Oh, my public ground. You know, when they finally chased me down in the car, and you know, who are you with? Are you with an agency? Are you with the air board? Are you with the water board? We don't want any agencies around here. It's like, dude, it's California. You have agencies that live here, right? I said, all right, here's what I do. I teach a lot of classes, right? I take a lot of pictures from the public access way, right? And just so you know, do SPCC plans. I didn't see any containment, just so you know. Should somebody show up, they're going to look for secondary containment. We have a plan. We have facility containment. The entire facility is contained. I couldn't see it at all, right? But that doesn't matter, because if you're an inspector or you're this facility, what do you want to see in the plan? You want to see the topography. You want to see the grading. You just don't want to have somebody say, yep, it's adequate. So if you're this facility, I would have topographic drawing. I would make sure, yeah, this is where it drains to. I would verify that. And just to keep idiots like me, I would just put in a berm here, just a rollover curb, just so I don't stop. And that's what it sounded like when that guy chased me down. And we're doing Riverside County's APSA Inspector Refresher Training a couple months ago, and you know, this is out in their jurisdiction. Like, hey, I know those guys. Anyway, double wall tank, right? What kind of tank is that? Storage tank. Well, it's a containment solutions tank, right? Is that a single wall or double wall tank? Looks like a double-walled tank. Right? How do you know it's an annular space? Superwoman? Oh, yeah. I thought you were, like, looking through the tank. Yeah, you look at... I know. You know I love you. There's all kinds of stuff on there, right? There's a fight. What? I don't know what's on the other side. All right, anyway, all right. Anyway, right? Here's another tank. You people are unruly. Here's another tank, single or double wall. Maybe there's other fittings on top, but they're hidden by auto parts. I don't know. It's square tank, right? It looks like that. And there are some plan writers who will just write it down that the double wall. There are facilities that have no idea what the difference is. If you can see it, try and take a look at the plate. They're both by Containment Solutions. These are both UL listed tanks. How do you know one's single, one's double? One says secondary containment, one doesn't, even though they may look the same. Always have whoever's doing your plan verify it. However they do it, have them verify it. Because sometimes they look the same. UL 142 tanks, single or double walled? Both. Right? Single or double walled? I don't know. Let me look at that. Notice how this is upside down. I'm like bent way the hell over the tank. Look. Right? Single or double wall tank? Single. Yeah. Or does it say the capacity of the secondary tank is? It's a single wall tank. No, if it's a double wall tank, it'll say secondary containment tank. Yeah. But it doesn't say secondary containment tank. That's what the UL standard requires. Right. Or it will say primary and secondary. If it just says primary, that's all there is. Yeah. Anyway, single wall tank, secondary containment, right? You want to measure it, make sure it's adequate. Does this tote have secondary containment? Yes. Is that sized? No. Does it have to be? Yes. Is this facility screwed? Yeah. Nah, they're harsh you people are. All right, smart guys. Drum set, what kind of containment do these things have to have? Size, contain 55 gallon. Nah. Now, people who sell containment pallets, they sell all kinds of containment pallets, right? You need to check the specs. Some are 5, some are 11, some are 66, you know. And that's a problem with a lot of facilities. Hey, go buy some containment pallets for these drums. And they grab the New Pig catalog, they grab the McMaster car catalog, and they buy anything that looks like that. No, they sell some that are not adequate for the required volume, right, for different uses. Generators, right? How do you know it's a generator, a double wall base tank? Well, the obvious stuff is primary vent, secondary vent, 2 drain plugs. One says primary, one says secondary, one says primary, one says base. You know, one says main, one says drain, one says main, one says bunt. Huh? Bunt tank or bund tank? Bund tank. That's British for secondary containment tank. I learned that on Google. All right. Anyway, for example, this generator, we couldn't tell if that was a double-walled tank. There's no way to tell. We'd have to take it apart to find out. Now, this is LA County. LA County says, oh yeah, it's specified in the purchase order from 1950 something. Well, you can go down to County Hall of Records and look for it. And I calculated this out. It was cheaper to engineer and build secondary containment than it was for even one of my staff go down to LA County and try and find the records. You know, so that's what they did. They just poured containment, they're done. I'm not sure that was actually size containment, but you know. This is the emergency generator, the old generator for the LA County Coroner's Office. They really need to keep that thing running. Sometimes you have to crawl inside a generator to figure it out. Safety counts, right? This is where little interns help, because they can. Hey, we put them in Nomex. you know, I hire Coster's daughters as interns because they're wiry. They can get all up in there. Right, so you're looking for the tags, you're looking for the vents, right? Sometimes it's very difficult to tell. This is way the hell inside this gigantic generator, like your body is like 3/4 inside the housing, right underneath the caution starts automatically sign. Right? And a lot, you know, and when you're writing a plant, this is what you have to do. Right? Just to be able to prove it, right? Hey, secondary containment, there it is. All right, I'm good. Very good. Right? You can't tell. You just don't know. You know, sometimes you look on the panel, hey, look, it says leak alarm. All right, so for portable containers, it still has to meet 100% of the capacity plus rainfall if it's exposed, right? The right kind of pallets, the right kind of tote containment, the right kind of containment. They use this thing for portable containers everywhere, and these are very light. They just stick them there and put the ramp up. Very nice. Yeah, it's very nice, very nice. Welcome to Samoa. All right, so how much, you know, adequate capacity, right? Freeboard above whatever 10,000 gallons it'd be, freeboard, rainfall up here. You know, 24 hours, 25-year storms, very typical. Don't forget, this is different than fire code. If this were a tank inside, under, you know, if it was like a, you know, class 1, class 2B, or, you know, combustible, if there's sprinklers, if it kicks in with the fire code, say H occupancy, how much water has to be held up for fire code? 20 minutes of full flow. That's a lot of water, depending on how big this is, right? That's not an SPCC requirement. You do, but any decent SPCC writer ought to have at least enough knowledge of fire code to raise the question, or to know when to keep shut when they're talking to the. Anyway, full capacity. You think that has full capacity for 55 gallons? Oh yeah. How about rainfall? Oh yeah. Yeah. How about this? 55 gallons? Maybe. Probably not with 5 inches of rainfall. Maybe they ordered all these with minimum 55 gallons, but these were designed and intended for inside the building. But just operationally over time, they started getting used everywhere. This is where inspections count, the right detail on the inspections, implementation, not just what you say in a plan, right? Anyway, you could buy all kinds of different pallets. Somebody should check the specs. Price is right. Nice containment, right? Has a drain valve. Think, is this adequate for 55-gallon drums? It'll hold 55 gallons, right? How about rainwater? Yeah, what if it's a couple inches of rain? 5 inches of rain? Yeah, it's a 6-inch or so, 7-inch burn. Yeah. Anyone see an issue? Not you APSA class folks, because we use the slide. What the hell is that? That's a roof drain. Or as we call it, vernal falls. You know. No, that's a roof drain. That's a roof drain. That roof drain should like just, you know, go to Home Depot, right? Little heat, and that'll be okay. But that's, again, there's a disconnect between, you know, people write on a plan, what do you have? You know, whoever's visiting the facility really needs to look around, right? Just not be focused on just look around. New product store. It very well could have. New product, yeah, new product storage. New product. You thought it was one of my facilities, right? Anyway, for mobile refuelers, non-transportation related tank trucks, sized or general? General. So these guys have some small drive on, drive off. This is inside a building. They have really heavy duty drive over 1-inch, you know, containment, the roll up doors.
So general can be allowed for a truck that may be used maybe once or twice a week and not attended versus?
It is a mobile refueler or other non-transportation related tank truck. Now, we're not talking about a bulk fueler where it drops its trailer and that trailer's sitting there. Now that's storage.
I'm just thinking of our mobile refuelers for our aircraft.
Yeah, but they're mobile refuelers, general containment.
My understanding, though, that if they were not used over time.
2008. Well, I mean, if they're in storage and they're not being used, that's an interpretation issue. But if they're in use, you know, that's they're
Like once every 3 days?
that's their mobile refuelers. General containment for a mobile refueler with biodiesel. You could take it right out of here, right into the turkey deep fryer. There's a reason why UL doesn't list those. I got that from Bob. All right, sufficiently impervious. We kind of touched on this. Sufficiently impervious to retain oil until it can be detected and cleaned up. Is this sufficiently impervious to retain oil? Yeah, you know, if there's no surface water right here where it's going to soak through here and squirt out, yeah, that's fine. How about this? This is for a substation? Yeah. Maybe they need to start working on this, but yeah, that's fine, general containment. It's going to soak right in, gravel bed. And then it goes into the ground. Silly girl, waters of the state versus navigable waters. Different. This is not impervious. Right? This is not impervious. Used to be. Not so much. What's another issue besides the unimperviousness of that containment that you see? Well, maybe they added a tank. I don't know. Maybe they added a tank. You know, maybe they got a tank cheap on eBay where it's leaked and had fire damage. I don't know. But that raises an issue. Management of change, right? But these tanks are painted green, so they are environmentally friendly. All right, discharge prevention positioning, right? 112.8 C11. In addition to the size containment for portable containers, they have to be positioned to avoid discharge to navigable waters. There is no criteria for that. All I know is don't put them over the storm drain. Put them some distance away. Even if this had containment, that's not where you should put them. Yeah. Yes, good. Yeah, that's a good point. If these were being attended, operationally attended, and the drain wasn't there, yeah, general containment is sufficient for containers in attendance. But that guy goes to lunch, guess what? Yeah. If it goes out to the stormwater, navigable water, if that goes to a separator, that's fine. Problem is you can't really tell by looking at it. And this, no, actually, this goes out to a harbor. Right. Yeah. Oh. That's size containment. It's not in transportation. And that is a longer discussion. Rail cars are a longer discussion. We could do it after, but that's a little bit longer of a discussion. That's the same question. The rule allows that if they're operationally attended. Delivering it where? Over the road? Yeah, that's being attended. If nobody's attending it. Yeah. Don't park your mobile refueler over the storm drain. Just don't. No. No, it's not. I don't mean to get, no. It's not. All right, anyway, discharge prevention, valves. Valves in containment have to be kept closed. That's all I could say. They have to be kept closed. No automatic pumping, right? They have to be kept closed. Sounds easy, doesn't it? Right? Problem with drains like this is what? They're made out of plastic is the problem with these, right? They're just, plus you put the cap on it and they're hard to see, but they're made out of plastic and they break. What's the problem with this, aside from the fact that it's missing a handle? It's missing a handle and possibly the valve is broke, right? What's the problem with that? That's a brand new valve. What kind of valve is that? It's a gate valve, right? Are gate valves allowed? Yes. What kind of valves are not allowed? Flapper. You can be on the ESCI team. Flapper valves. Yeah, flapper valves, right? But the only problem with this is operational. Can you drive by, tell if this thing is open? Not usually, no. You have to get out of the cart, walk over, take a look at it. Over time, it's going to be kind of a hassle to do the inspection, therefore, less likely it's going to get done correctly. What if that valve gets silted up? What if it gets, you know, you can't, maybe you can't shut it all the way, but you're still turning the handle, and all of a sudden the handle stops. Okay, it's shut, and it's not. But it's okay to use these. I really prefer the ball valves. It's either open or it's not. You know, how do you know that thing's closed? It's perpendicular to look at it. And it's easy to latch it up, right? How about that? What are the issues there? Yeah, there's all kinds of silt and sand there. It's operational. The plan is fine, right? The plan says, yeah, we keep valves closed, you know, they're inspected, da-da-da-da-da. You know what, but for you plan writers, you know, if you see stuff like this at a facility, you know, just tell, hey, look, you know, you really ought to get rid of the ball valve, or you really ought to get rid of the gate valve, go to ball valves. You just should.